Okay, so on this question, we've got people typing a manuscript and they make errors at random, and we've got the number of errors they make per page. So this is a mean rate, so this is a Poisson question. Okay, so in the first part, we're taking a random sample of M pages of Tim's typing. Now, Tim makes 0.45 errors per page, so if we take a sample of Tim's pages, M pages, which I'm going to call TN, that's going to come from a Poisson distribution. And with Poisson distributions, assuming that the errors made per page are independent of each other, we can just say that the mean number of errors per page is going to be 0.45 times n. And we've taken our sample. It says the probability that these M pages contain no errors is less than 0.05. And we've got to find the smallest possible value of n. So here, what I'd like to do is use the formula. So in your formula book, you can find in the stats section the formula for the probability of equaling a value for a Poisson distribution. So using this formula, it's e to the minus lambda, then lambda to the power of x over x factorial. Now, I actually don't need the these two terms because they're both equal to 1. And what I do with inequalities like this is so that I don't make an error, because we might end up dividing by negative numbers and then we'll have to switch the inequality around, is I'm just going to make that equal to 0.05. Okay, so we've got negative 0.45 n equals 0.05, and then oops, equals ln 0.05. So taking logs. Okay, and so we can get that n is in 0.05 divided by negative 0.45, which is 6.66 to three significant figures. It doesn't really matter because you can't, n is a sample of pages and n is going to be an integer. So then we've just got to think, so which way is it going to be, n equals 6 or n equals 7? That's going to give us the less than 0.05. If you're not sure, just try it in your calculator. So just go into Poisson mode, put lambda as 0.45 times 6 or times 7 into your calculator and try it out. But it's going to be n equals 7 is going to be the smallest possible value of n, because the more pages we get, the less likely it is there's going to be no errors. Right, so once we've done that, and now we're told how many pages. So we've got the number of errors in a sample of 5 pages of Tim's typing and 5 pages of Sue's typing here. So what have we got? So I'm going to say x is the number of errors in a random sample of 5 pages Tim's typing and 5 pages Sue's typing, and then x is going to come from a Poisson distribution. So 5 pages of Tim, we can scale that up. And remember, as long as if we've got 2 independent Poisson distributions, we can add their means to get the mean, overall mean. So 5 pages of Sue's typing. Okay, so it's going to come from Poisson distribution with lambda 3.25. After that, it's just a case of putting that into your calculator or using the formula. So I want the probability of x being 2. Okay. Just actually stating the question, 0.248. I've just done that for significant figures. You need 3 significant or better. Now, here, it's very easy to miss the second part of the question, which is stating a necessary assumption. So make sure you don't miss the second part of the question. So the necessary assumption is that we assume errors made Right, Tim and Sue have to be independent of each other. Okay, you can only add the means of Poisson distributions if they are independent of each other. Okay, now the last part here, they're doing random samples again of 5 pages of Tim and 5 pages of Sue's typing. So you would think this follows through from part B, but actually it doesn't. We have to do some more work. The only thing that we know is going to be the same is that from that sample that follows a Poisson distribution with mean 3.25. Right, so what we want to do is we want the probability that in 10 of these samples there are 2 with no errors. Now what's changed here is now we're talking about this number of samples and we're not talking about the number of errors. So this is now changed and we're now talking about a binomial distribution. We've got 10 trials and we want the probability that there are at least 2, y is greater than or equal to 2, with no errors. So to find out our p, that's the probability of x, which was from our Poisson distribution, being 0. So that doesn't follow directly from b. In part b, we found the probability of being 2 errors, and we now want the probability of 0 errors. So using our Poisson distribution, probability of that being 0 is 0.03877, if you can work that out in your calculator again. Right, so if y is the number of samples that we want now, I'm going to say that comes from a binomial distribution with n10, and the probability of no errors is what we've just worked out. And so I want the probability that there are at least 2 samples with no errors. No errors. And so in your calculator, so either in your graphical, you can do that directly, or with the ClassWiz, you might need to write that as a summation. You can then work out that that's 0.0550. If you need to write that as a summation, you've got the formula in your formula book for the binomial distribution, and then you can just work out the sum from 2 to 10.